Hello everyone, and today's video will be talking about the stack and implementation of a stack using Python. So, what is basically a stack? A stack is a fundamental data structure in computer science that follows a basic principle, that is last in, first out principle. Okay, so this means that the last element that is added to the stack is the first one to be removed. Like, for example, we take an example of the stack of plates, where you can add or remove the plates on the top. So we're taking here example, like we have example of here we have like I've taken three examples. So in that examples, uh this one, like we take the stack of the coins. So this coin, it is the first one to be added but the last one to be removed. When we start removing the elements, this would be the first one to be removed. This will be removed first. This element, the first element to be added, the last element that would be removed. So just like that, we have this a stack of the rocks. Here also, this is the first element that is added and the last element that will be removed. So okay, after that we have the last in first out principle. So this is the basic how a stack works. So here we have an empty stack. So in that empty stack, will apply a push operation here. Push. So here we keep adding on the stack, and if you want to remove an element, for that we'll use the pop function, and to add we'll use the push function. So okay, here we take like an example. This is a stack. Okay, we consider this is a stack, and in the stack we start, adding the elements. So this will be the first element to be added, and after that we'll add another element, which will be like this. And as we keep on adding the elements by using the push operation. Push is basically means we are adding the elements in the stack. Okay, so now we have made a stack and we have added the elements. As we start removing the elements, okay, now we have added the elements in the stack by using the push operation. Now, if you want to remove the element, like we have put the plates like one above the another. If you want to remove any of the plates, like the top one plate would be removed first. So just like that, we're gonna remove this one first. We're gonna remove this one first, and then this one would be removed, and then this one would be removed. So just like that, we have this three. So this will be the first one to be removed. This was the last one to be added, but the first one to be removed, and this was the first first. So uh, by this we understand that it follows a basic principle that is called LIFO, which basically means last in first out principle. Last in first out principle. The element which is added at the last will be the first one to be removed. So with that, we have understood the stack properly. Now we'll go for the implementation of the stack by using the basic function which it has, that is push, pop, peek, and the last one is size. Push is like pushing the element. Push is like pushing the element we are adding here. That is the push operation. And if we are removing a stack, if we are removing an element from the stack, this This is called pop operation. Pop means removing the element from the stack. And if we want if we want to access the top element of the stack, here we use the operation that is called P. And to get the size of the stack, we use the operation size. If we want the length of the stack. So now we have understood what the stack is, what is the function of the stack. Now we'll come to the implementation part to understand it well, how it is implemented using Python. So for that, firstly, we will define a class stack. And yeah, firstly, in that, we start defining the function. First one would be the initializing function, that is init, and that init function will be defining a stack, which is self dot items. And then firstly we will check, now we've defined a stack. Firstly we'll be defining the function to check if the stack is empty or not. To check if the stack is empty or not, we'll be defining is empty function, where that is self is empty. Self will return length self dot items is equal to 0. Firstly it will go to the length of the stack. So if the length of the stack is equal to 0, then it will show that the stack is empty. It will return to true. That means the stack is empty. Then we'll start adding the elements to the stack. So to add the items to the stack, we have push function. So we'll be defining uh, push function items. It would be the value of it will be the like elements, the items which we are going to add in the stack. So to add in the stack, the function we have is append function, which will add the items at the end of the stack. As if the stack is empty, it will add the element at the bottom, and the second element at the top of the bottom element. So it will keep adding like that. So we'll append items, which we have given there the value of the items. And then once we have done adding, like one by one, we keep on applying the push operation. We keep applying the push function. We keep on adding the elements. Now to remove an item from the stack. To remove an item from the stack, we'll be defining pop function. We'll be defining pop function. Here we have, so to remove the element for from a stack, firstly we have to check if that if the stack is empty or not. So if the stack is empty, there will be no item to be removed. So firstly we'll check if self dot is empty. Self dot is empty. If stack is empty, we'll apply a is empty function here. It will raise sorry index. It will raise an index error that the stack is empty. Uh, the stack is empty. no item to be no item would be removed or no item to be popped. Return. So if the stack is not empty, then what will it return? It will apply a pop function, that is stack dot items dot pop. Wait, sorry, pop. And now we have done. So it will run the pop function. It will remove. So if it's empty, then it will show that it's empty, and if it's not empty, it will start popping the top element. The top element would be pop, and if we again apply the pop function, the second topmost like the top would be popped, and after the second one would be popped. After that, we have a peak function. Peak function is used to peak the top item in the stack. So we have peak function. So here we have peak if self dot is empty, then it raise will raise an index error that stack is empty, no element to peak. Or we can say no item to peak. And if the stack is not empty, it will return self dot items one minus one. So if the stack is empty, it will return that the stack is empty. There is no item to be picked. And if the stack is not empty, then it will return the self dot items minus one. Minus one here is like length minus one. That means the topmost element, because the index start from zero. So in the stack of the 10 elements, the last element would be on the index 9. So for that we have written minus 1, that will return to the topmost element, that is the element with the ninth index. So after that we have to get the length of the stack. To get the length of the stack, we have a function which is size. Like if we want to find the what is the length of the stack, it will basically return to the length, that is self dot. And now here we have then we have another function, that is to display the stack. To display the stack, we have a function to display, and in that function display cell. It will print it will print that this is our stack self dot items. Now we have defined all the function. That is like taking an example here. Then we have an example. So here we have Alright. Okay. We'll be defining stack is equal to stack the class which we have defined before, and that will be defining different. Firstly, we'll be adding two or three elements in the stack by the push function. We have 29. I've added the elements. I want to display my stack dot display. So firstly, we'll after pushing the elements, firstly I want my stack to be displayed. So if I'll run this, yeah, my stack is displayed. So this was my stack, that is 29, 30, 31, and 39. So if I want my size of the stack, so we'll apply the size function first. Rent stack dot size. So yeah, we'll be adding our size of the stack. Now I've pushed the elements. Now I want to pop some of the elements. Like I want to pop the 39 and 31. Uh, so for that we'll be applying the pop element. So we have stack dot of pop. So if we apply the stack dot pop function, it will remove the top element. So wait, before deleting the element, firstly I want to peek the element. So we'll be printing. Firstly, I want the top element. I want to check what is the top item in my stack. Top item, and then we have uh, stack dot peek. So here it will show that my top item is 39. Now I peeked. Now I want to delete this item again. Firstly, we have this four items over here. There is 29, 30, 31, and 39. So, and this was our length, and the top item was 30, 39. Now I've deleted the top item. Now our stack will look something like this. That is, we have 29, 30, and 31. We have just three elements. Now, if I again want to pop, I'll again apply the same, that is stack dot pop, stack dot pop, and then I want my stack to be displayed. Then it will again display a stack by my element has been popped. Now again popped one element, that is like now my stack has my stack has only two elements, that is 29 and 30. So with that we have applied all the functions. I hope you understood it well. Thank you.